Hello guys, my name is An. I'm the team leader of Team Fortress. I have two teammates, Wing and Tang. Today we're here to present our design of team formation system. So here's today's agenda. First I will give you guys an overview of application, then I will present to you guys the key feature of this application. Next I will go over the performance criteria and the constraint of this application, and then I will go over the design of our application with a class diagram. Next, we will go over the use cases and their respective diagram. Finally, we go over the project management steps and test plan and development schedule. Before I get started, I would like you guys to know that we will go over things really quickly in this presentation. So if you want more detail about this presentation, please click the link in the description below to view our SRS. Now, let's get started. So, what is Teamster? Teamster is a team formation system. A team formation system is a system that is designed to match students with capstone project to suit their ability. Here are several key features of this application. Uh, First of all, it has to match student with project that suit their ability the most. So how does it work? Each project will have a set of hard constraints, must have quality that the student must have. If a student does not have one of these quality, he or she will not be considered a suitable candidate for this project. Next, the system will consider the sub constraint, aka weighted constraint. Think of it like your grade in a subject at school. The higher your grade, the better you are. So, and the sum of these weight is called fitness score. The system will attempt to match the student with project in a way so that it results in the highest overall fitness score across the project. Next, the next key feature is the ability for it to display fitness score to the student. And finally, the system also allows manual members swap between teams with the teacher approval. Several performance criteria of this application include in terms of availability, the application should be available 24/7, especially in the beginning of the semester when the traffic are really high. In terms of response time, it does not need to be really quick because most of the tasks of this application are not time sensitive. So they only need to support this application only need to support average response time. In terms of security, the app holds sensitive information such as name, telephone number, addresses, and academic status, so it should be very secure. In terms of mobility, the application should support popular browsers such as Chrome, Firefox, and Internet Explorer 8 and above. Optionally, it should support multiple screen sizes across different devices. And finally, for maintainability, it's unlikely to receive any feature request because the application is only supposed to do one thing and one thing really well. And most maintenance tasks will be about bug fixes and UI improvement. And as for in terms of constraint, the performance of the application will depend on the school server. The application must use the school login system. The UI design of the application must adhere to the school style to maintain consistency, and an internet connection is required to use this application. Maintenance tasks such as big updates should not be carried out at the beginning of the semester. The app will use the same database with the school, so during the high-low period, the app may slow down due to increased query time. And here is the class diagram of this application. The most obvious relationship is the inheritance relationship. For example, the client, student, and lecturer classes inherited from the user class, and the hard constraint and soft constraint classes inherited from the constraint class. The next type of relationship is aggregation. For example, the project class should have a list of students And if the project class is deleted, an instance of the project class is deleted, the student should still class should still exist. Thus, that's why they have a aggregation relationship. Similarly, the project class has an aggregation relationship with the TFM class. And finally is the composition relationship. Since a constraint must be created by a creator, so we can say that the constraint has a composition relationship with the lecturer, student, and client classes. Additionally, when a project is deleted, any kind of related constraint that is real will be deleted as well. So the concept will have a composition relationship with the project class. And finally, the project class will have a composition relationship with the client as well. For whatever reason, when a client account is deleted, every every of his project will be deleted as well.
So hello Anna, I am Kang, a member of Teamstar, and today I will show you some of the use case we propose in the project. The first one will be the view fitness score. The main actor of this use case would be the student, and whenever they want to view the fitness score for the project they listed, they can click on the button in the main page and they will be directed to this user interface. You can explore the project to the slide to see more clearly as we had time constraints, so I wouldn't go through it. So here, within this slide, we will have two diagrams, that is data flow diagram and activity one. But now I will only talk about the activity one. So the lecturer can initiate the project by logging in, then request the fitness report for the student and enter a report format info. Then the system will gather the data, generate a report, and serve a report back. And then that's at the end of the activity diagram. So the second use case I'll be presenting is creating a project. It allows the client to create his her own project, and only he or she can modify them. So from the main page, the user can click on the new project button, and this small window will pop up. All the necessary information will be shown here, and you have to fill all of them out before submitting it. So I will move on to the next slide. So here we will show you two diagrams, the sequence diagram and the activity diagram of it. Now I'll go through the activity diagram. First you have to log in, create a project button, and then enter all the necessary information, and then enter the contact information and confirm it. All the other things like validation will happen before the life cycle ends here.
Hi Anna, my name is Wing. I'm a teammate in a team project. Today I will talk about UK swap teammate. The actor in this UK is a lecturer. When a student send the request, the system will notify to the lecturer will receive this request. And when choose any project, they will redirect to the detail page. And if the lecturer approve this project, the successful message will send to the student, else the failed message will send to the student. This is the data flow and activity diagram of this use case. Now we will talk about discuss unpopular project UK. The actor in this UK continue to be a lecturer. When the lecturer log in, they will click on the notification on the bottom right of the homepage. The link of unpopular project will display. To view the detail of any project, they will click on the detail button, and to delete the project, click on the delete button. And when click on the delete button, we will receive a confirmation, and click on the OK button to confirm, or when click on the cancel, we'll cancel the deletion project. And if they want to see more, click more button. And this is the sequence diagram of activity diagram of this UK.
Hello again. Now I'm going to present two final use cases in this presentation. The first use case I'm going to go over is create a preference profile. The main actor in this use case is the student. A student needs a profile for the system to match him or her with a project. A student can just visit their home page and are free to edit or add any preferences that she or he like to add, and click submit to apply the changes over here. And here's the data flow diagram of the this use case. Is, as you see, once the student enter the preference profile information, the system will receive the information and validate it. If the information is valid, the system will save it to the database. If it's not, the system will ask for clarification. And this is a activity diagram of this use case. The next use case I'm going to talk about is to create a constraint. The main actor in this use case is the lecturer. The lecturer can edit, delete, and add any constraint on any project that he or she he or she just need to choose a project on this list, and the information of that project will be displayed in this section of the website, and the lecturer can start editing as he or she like. And here's a sequence diagrams of this use case. Right, first the lecturer need to visit the home page, and then the system will retrieve the home page for him, and the lecturer just need to choose a project and start editing the project. The system will verify the project and let the new information, and let the lecturer know of the result. And here is the constraint. Here's the activity diagram of this use case as well. Alright, on to the final part of the application, project management. And here's a development schedule of this project. We will use waterfall methodology since the requirements are quite clearly defined, and it only takes approximately 18 weeks to be completed. And here's a timeline of our application development phase. We'll spend 1 week in the requirement gathering and analysis. Here we will gather the requirement from our client and analyze them. And we spend 1 to 2 weeks to design the application and test different design. And we spend 8 weeks in the implementation phase. This phase is split into two parts. The first part is developing the backend API and the business logic. The second part is developing the user interface and integrated it with the backend API. We spend 6 weeks in the testing phase. The testing phase split into two parts as well. The first testing phase will include functional tests such as unit integration and system testing. The second testing phase will include the user acceptance test. And finally, we will spend 1 week documenting the code. And now it's truly final. We will start to deploy the application. The maintenance phase will last as long as the contract specify. And here's our test plan for this application development. We will conduct 4 types of tests: unit testing, integration testing, system testing, and finally acceptance testing. Our testing phase will last approximately 6 weeks. We spend 2.5 weeks on test specification, 3 weeks on test execution, and 0.5 weeks on writing the test report. The application is considered to pass the testing phase if it has more than 85% pass rate in all the tests. And that is the end of our presentation. Like I said in the beginning, guys, because we have a time restriction, so we have to skip a lot of detail to make the time. So if you guys want more detail, please click the link in the description below. Other than that, thank you for listening. Goodbye.